welcome back to another episode of Hack Code. Today we are delving into the classic coding example that tests both our problem solving and algorithm skills. So that's LeetCode 15, 3 sum. Let's delve into the question. So given an integer array nums, return all the triplets such that the three triplets sum is equal to 0. Here I, j, k are different positions. That's what it means. I is not equal to j, I is not equal to k, or j is not equal to k. And notice that the solution set must not contain any duplicate triplets. So let's go over examples. Here this is a given array. Output is expected output is this one. So explanation, because we have these three indices, sum is equal to 0, we got this 3, and out of this same for these two, the distinct triplets are -1 0 1 and -1 -1 2. So we got this triplet here. These are duplicate triplets, right? 0 1 and -1, but we have it here only -1 0 1. So this is a triplet. So we should avoid these duplicate triplets while picking the solution set. That's the main catch here. So in the example 2, there is only one possible triplets. Because there is 0 solutions, we give it as a 0, because there is nothing that sums up to 0. So we return as an empty array. Here also, because everything is 0, the only possible triplet is 0. Rest all others will be like 0 0 0. Like rest all others will be same thing, right? It's a combination of 0 0. So we don't consider all those. We just consider only one set. Since we need to eliminate all the redundant things, we just consider only one. They said, right, set must not contain duplicate triplets. Hence we choose only one triplet. Hope you got overall idea of question. So this is a very typical examples of how we gonna solve the problem. So notice I'm just reiterating again, we are not considering 0 1 and -1 because we already have -1 0 and 1, right? Just keep a catch of it. We'll see the solution. So first let's start by discussing the brute force approach. So here we have to it's just a basic thing, right? For this we need to find some of the element which maps to 0. So in this method, brute force method, we'll just iterate to the array and try every possible combination of 3 elements, and then we'll check if the sum of those 3 elements is equal to a target value, which is 0. While this approach works, it's not the most efficient, especially for the large arrays. So the time complexity of the brute force is O of n cube, which is very slow for the larger inputs. So for this approach, the first step is to sort. The array is sorted at the beginning, which allows us to easily skip over the duplicates by comparing each element with its predecessor, like the one which is before the element. So this is crucial for ensuring that we don't count the same triplet more than once, like we discussed in the given example. So iterating to the nested loops next step is. So this snippet, we can see that we are systematically check every possible combination of the 3 elements within the list. So each loop starts from a different index to ensure that we are always looking at the unique set of 3 numbers, and we always skip duplicates here. That is the main step. So after sorting, if we find any consecutive elements in the array that are identical, we skip those to avoid checking the same triplet again. So this is done for each of the numbers we are selecting I, j, k. So and at last time main step is we check for the sum. So for a unique combination of I, j, k, we check if the sum is 0. So if it is, we found a valid triplet and we add it to a solution set. So I'm just iterating the code again. I just told approach. So here first we sort the array to help identify the duplicates. Next we iterate through every combination of 3 elements, like using 3 loops. So we iterate till the length of the array, so n. So since we see in the example, we should be like eliminating the duplicates. That's why we are checking only for I greater than 0, because we can't check the negative element, right? Like we should check if it's the same element equal to the element is same as the previous element. That's why we need to check I minus 1. But if it is I is equal to 0, it would be nums of -1, which should give us our index out of bound exception. So that's why we need to have a check of I greater than 0, and we should consider only when there's a index is I greater than 0. And the case is like when I is nums of I is equal to nums of I minus 1, this is a duplicate scenario, so we should skip it. So we're using continue here. So second step, same, we should pick the next element apart from I, so that's why we're using I plus 1. Here also same, we check for the toward the duplicate picking, we use I plus 1. So for just for our understanding, let's consider I j is equal to I plus 2. So we're checking if nums of I plus 2 is equal to nums of I minus 1. I mean nums of I plus 1, because plus 1 plus 2 minus 1 is nums of plus 1, I plus 1. So we are considering if I plus 2 element is equal to I plus 1th element basically in this step. So if it is same, then we continue, because we shouldn't pick the duplicates, right? So that's what we're doing. So same for here, k is equal to j plus 1. So consider j as like consider k as j plus 2. We are checking if j plus 2th element is equal to j plus 1 element. That's how. Where j is equal to I plus 1. So hope you got the point. And then now we're checking if our sum meets the target, that is 0. So if sum meets the target, then that's where we found the triplets required. Once we so we add it to the array, output array. And then since only a valid triplet, once a valid triplet is found, we don't need to check further for k. So we break, right? Because we don't want a duplicate. Like we already got a valid element, and we're checking for eliminating all the duplicates. So we break out of this loop, and we are interested only in the unique triplets. So we move out of the loop here. So next is using two-pointer technique and set. So this is what is two-pointer technique. So we keep first here also the sorting step remains same. The only thing difference is we use a two-pointer technique, which helps us to reduce the time complexity to n square. So in this method, we'll sort the array first, and allowing which will help us to use the two-pointer technique to traverse the array. I'll come up to two-pointer technique later. So we'll fix one element and then use the 2 pointers to find other 2 elements such that the sum up to the target value is 0. But carefully we adjust these pointers, and then we sum we check the sum if it is equal to 0, and then it's the case like we fix the ith element at this point at the end of the array, and we keep these points moving. These are variable points for a given loop, and then if these 3 sum is equal to 0, then we found a valid element, valid set of result set. So we add it to the result set. That's how this approach works. So it's actually we're using 2 loops. So its approach is which is like n square. So we have quadratic time complexity, and that is n square, and which makes it more faster than brute force for a larger arrays. So let's go over the approach here. First step, we sort it, and then other side we keep I is equal to n minus 1. So we fix it for the for a given loop, for a given iteration, we keep the I as a fixed set, fixed point, like here, and the n minus 1 step, like here is the length of the array minus 1, that is the n minus 1 position. So here we initialize I is equal to n minus 1, and result is just we making set because to order the duplicate triplets. So since here we start with I is equal to n minus 1, but we have to come till I is equal to 0. So that's why we have to keep this as I is equal greater than 0 check here, and then we keep the left pointer and right pointer. Left pointer starts at 0th index, and right pointer starts at just like I minus 1. So when you see the example here, left starts here, right starts here, and I is remaining here. I is fixed for the given iteration, and where L and left and right point indexes changes. So here we while left less than right, because we should check only for the we should not consider left is equal to right case, but that's not a valid result set, right? That's why we just check. We should ensure all the set is it shouldn't contain any duplicates. So that's why we check till only left less than right. So we for given set we check like nums of I left and right is equal to 0. So if it is 0, then we'll just add it to the result set. So we just append it to the result set here, and then we move to the left to the +1 and right to the -1. Since we are done with this set of elements, we just move the left pointer to 1 and then right pointer to minus 1. So to find any other valid triplet. So if it is less than 0, it means that since we are in a sorted array, we have to consider moving plus 1, so left pointer to plus 1, so which would give the more possibility of getting sum is equal to 0. That's why we move it left pointer plus 1. So else case, like if it is greater than 0, since this is sorted array, we should move the right to the this like leftmost indexes to get the sum which is equal to 0. That gives the most probability. So that's why we decrement the right pointer to minus 1. So and then after this we iterate to the loop. Since we iterate to the loop, we should make the I minus 1. As I said, we keep I here and keep going down till here. So we have to check basically for all possible combinations. So I is equal to minus 1, and post of this, since we use the result as a set, we have to convert. They expect as a list. We converting a list set to list using the list of set. So here the time complexity is O of n square, where n is the length of the array, and space complexity is O of k, where k is the number of unique triplets. So this in a worst case, it would go up to the space complex could approach O of n cube. For very large inputs with a numerous combinations, but there is an extreme and impractical scenario for which we have seen, right? Like there is no solution. There would be O of where k is equal to 0, the solution set is 0. So there O of 0, the space complexities. But what matters in our example, in our problem solving, is time complexity, because these days storage is cheap, but the computation power is more, right? So let's solve this. So I have added this code already here. So let's execute with the brute force approach first. So I'm just running it. This runs all fine. And then it is accepted for just this minor set of solution. If we submit this, it would give us time limit accelerated for a larger data set. See, yeah, it is given time limit accelerated because the data set is very large. I mean, the given length of array is very large, so it would be having the time limit accelerated. Now we check out 3-pointer solution. Second, just copying this 3-pointer solution here, calling this function, method. So here, yeah, this you got the point, right? Here we're just adding to the result set and then add, just moving this left and right pointers. So yeah, it's accepted solution here. Let's try submitting this one. So yeah, accepted solution. So the conclusion. So in conclusion, solving three-sum problem question is like it's required a thoughtful approach that balances efficiency and effectiveness. While a brute force may work for a smaller arrays, the 2-pointer technique offers a much faster and more scalable solution for larger inputs. So by understanding the problem's nuances and leveraging the right algorithm techniques, we can tackle the most challenging coding questions with confidence. So thank you for tuning into this episode of Hackcode. If you found this video helpful, be sure to give it a thumbs up and subscribe to the channel for more coding tutorials.